And to begin with,
Let's create a cosmic catastrophe. Imagine that all of a sudden, and without any warning, the sun vaporizes and completely disappears.
now let's replay that catastrophe and see what effect it would have on the planets according to Newton. Newton's theory predicts that with the destruction of the sun, the planets would immediately fly out of their orbits, careening off into space.
In other words, Newton thought that gravity was a force that acts instantaneously across any distance, and so we would immediately feel the effect of the sun's destruction. But Einstein saw a big problem with Newton's theory.
A problem that arose from his work with light. Einstein knew light doesn't travel instantaneously. In fact, it takes 8 minutes for the sun's rays to travel the 93 million miles to the Earth. And since he had shown that nothing, not even gravity, can travel faster than light, how could the Earth be released from orbit before the darkness resulting from the sun's disappearance reached our eyes? To the young upstart from the Swiss patent office, anything outrunning light was impossible. And that meant the 250-year-old Newtonian picture of gravity was wrong.
If Newton is wrong, then why do the planets stay up? Because remember, the triumph of Newton's equations come from the quest to understand the planets and the stars, in particular the problem of why do the planets have the orbits that they do. And with Newton's equations, you can calculate the way that the planets will move. Einstein's got to resolve this dilemma.
In his late 20s, Einstein had to come up with a new picture of the universe in which gravity does not exceed the cosmic speed limit. Still working his day job in the patent office, Einstein embarked on a solitary quest to solve this mystery. After nearly 10 years of racking his brain, he found the answer in a new kind of unification.
Einstein came to think of the 3 dimensions of space and the single dimension of time as bound together in a single fabric of space-time. It was his hope that by understanding the geometry of this 4-dimensional fabric of space-time, that he could simply talk about things moving along surfaces in this space-time fabric.
Like the surface of a trampoline, this unified fabric is warped and stretched by heavy objects like planets and stars. And it's this warping or curving of space-time that creates what we feel as gravity.
A planet like the Earth is kept in orbit not because the sun reaches out and instantaneously grabs hold of it, as in Newton's theory, but simply because it follows curves in the spatial fabric caused by the sun's presence. So, with this new understanding of gravity, let's rerun the cosmic catastrophe. Let's see what happens now
If the sun disappears. The gravitational disturbance that results will form a wave that travels across the spatial fabric in much the same way that a pebble dropped into a pond makes ripples that travel across the surface of the water. So we wouldn't feel a change in our orbit around the sun until this wave reached the Earth. What's more, Einstein calculated that these ripples of gravity travel at exactly the speed of light.